My name's Alex. I'm a full stack engineer here at Kaleido, so I get to do everything from building front ends to writing Solidity contracts and some building smart contracts. And I'm really excited here today to just talk to you guys about some tools that I'm really passionate about as a developer that make my job easier, for building Web3 applications. So just to level set here, and so what are we talking about? I grabbed a snippet off Wikipedia. So really Web3 in this case is just applications that are focused around being built on a blockchain. Especially in the enterprise space, we like to call this kind of as a multi-party system. So you have multiple members of a consortia, multiple businesses, all in the same network around a blockchain, and building applications to utilize this. They can communicate with one another. So as a developer, there's some unique challenges for building these Web3 apps that you don't normally have with normal centralized, Web 2.0, you can call it, applications. In a business network, I need to be able to register members and communicate with them. Digital currency is really one of the powers of blockchain, the ability to preserve value on chain through digital assets. I need to be able to code to that and be able to utilize that in my application. There's, I have my own private data store, and I need to be able to pin that on chain and communicate with another member. Things like being able to keep my own data private. And then really, I really just want a concise REST API to be able to do all that with, right? And these are all things that out of the box, I do not have as a developer, right? So I hope to show just a couple tools to take you from, I'm writing a smart contract to I'm actually building an application with it. So really we just want to be productive fast. We want to be able to ship applications and write our business logic and not kind of worry about some of the more complex things, because I hope the tools I choose will do kind of the hard stuff for me and just empower me, to build my application. So one of the cool things about this space is there's a lot of really, really great open source projects to do all kinds of things. And I wish I had the time to show all of them, but there's a couple here that I use that I'm really passionate about. So I wanted to give you guys a glimpse, and we get to see them hands-on here in a little bit. So the first one, smart contracts are just a core, foundation of Web3 decentralized applications. And so I really like, a project called Hardhat, which is developed by the team at Nomic Labs. It's open source. I encourage you to go check it out, but really it gives you just a full, Ethereum Solidity focused development environment to do all sorts of things with your smart contracts. So the great part is I can write, locally in my editor Solidity code. I can use Hardhat to compile. A really nice part is it has, TypeScript support out of the box. So I'm able to, as I compile my smart contract, immediately get types that I can use to test. So let's say I'm testing and there's a bug in my smart contract. Well, Hardhat provides a debugger and different tools you can use to actually get hands-on locally on your machine and debug your smart contract. And I think really the selling point is it just accelerates Solidity development and makes it easier, right? And then just next, a project that I'm really passionate about. I am a maintainer, or one of the maintainers, of Hyperledger FireFly. It was seeded by engineers at Kaleido, learning from years of experience building these Web3, multi-party system type applications. And so FireFly, I mentioned earlier what Web3 looks like in the enterprise space, and FireFly is an implementation of that multi-party system. And I think of it as a developer, it kind of provides me an API to do the really, really hard bits of blockchain, and it does it for me. And for me, I can just call an API. It handles things like submitting transactions. It has, support out of the box for digital assets, minting, transferring, burning tokens of different standards, ERC20, 721, 1155. It handles on and off chain orchestration for you. A really cool part, which we're going to see more about today, the team has been pushing really hard for what we call custom contract support or on-chain logic. So really, write your own Solidity contract, write your own chain code, and bring it to FireFly and let us empower it, generate a really nice API for you. And a really great part is it's pluggable, right? I mentioned this, you can choose your own protocol, Fabric or Ethereum. You can choose your own public data storage. You can choose your own database for your private data store. It's really, really, really flexible, and hopefully to showcase some of that to you guys. But I think first, before I get into the cool stuff, it might be useful just to take a quick look at a picture of what FireFly looks like in a multi-party system. So here, you'll see each member has their own FireFly node, which has its core runtime, all of its connectors, the UI that Nick was showing off earlier, and each member has one, right? And all of this is built around, and the focus of it is a blockchain. And then FireFly handles all of the difficult things, submitting transactions. FireFly has a really rich event-driven API programming model. So it handles that for you, messaging, sharing my private and public data. FireFly handles that. So really, as a developer, what do I care about? I care about building my app, right? And so all I have to focus on is my app, my private database, and then interacting with FireFly. So it does all the cool things for me. One thing to note is what's really cool about multi-party systems are each application here, each member's running their own copy of it, but it's the same application, right? And each member has their own, private data for that application, but it's theirs, and they're communicating with each other through FireFly. So now I'm going to get out of the boring stuff and hopefully show off these two cool tools I was just talking about. So I'm going to switch to my terminal. Hopefully you guys can see. I'll blow it up a little bit. Just call me out if you can't. So first, let's start with the smart contracts, right? Let's show off Hardhat and how I can be productive with it. So the first thing, I'm just going to cd in the Hardhat directory. It's empty right now, but there is a CLI that I can run that provides kind of like Hardhat provides, so you can have a template. There's a few options. You can create a basic sample project. It gives you an option to create something more advanced. You can create something with TypeScript, which we really like TypeScript here at Kaleido, and I think it's a great tool. Or maybe you know what you're doing, you just want an empty Hardhat config, and you're good to go. So just wanted to show that off, but just for time's sake, I actually went ahead and created a Hardhat project myself based on ERC20. So I'm going to open this up in my editor. So there's a few directories here. We might as well just go through them. There's a contracts directory, and this actually takes where your Solidity contract lives. We're going to dive into the ERC21 here in a second. There's a test directory. So this is where all of my tests live that I've written in TypeScript. One thing I mentioned earlier was Hardhat generates types for you upon compilation. So I look in the type chain directory here, and I see there's types for all of my contracts that I've compiled. And this is really handy, we'll see, because in my test, I can then leverage these types to make me more productive and program safer. So let's just dive into the contract, right? So this is a simple contract that conforms to the OpenZeppelin ERC20 standard, and then extends it just a little bit. It has a couple functions here in addition. It has a mint and burn functionality. And so if we just take a look, they're really simple. It just takes a to and an amount. So who I want to mint tokens to, and then burn, who am I burning, what's the account, and how many I'm burning. Pretty simple. You can see it extends ERC20, and this will be really important later. So actually, what do we have here? We have a smart contract. Now I'm ready to start testing it. Testing is something that's, well, it's always important, but it's really, really, really important in smart contracts because of how expensive it can be if there's a mistake, right? While there might not be a lot of code in a smart contract, there's probably hundreds, if not more, lines of code that depend on it, right? So, if there's a bug, the ramifications can extend way beyond your smart contract, right? You want your foundation to be solid, and that's why it's important to write really, really good tests. So I'm going to open up my ERC20 with data test here. I just did a couple to show. If you're familiar with Mocha, this is going to look really familiar to you. So we have a describe block, which just kind of is a description of our overall test. We have the it blocks, which are individual tests that run. And then we have a before each block. And all this is doing is before each test, it kind of sets up some base functionality to be used. Just to walk through what's going on here, Hardhat has Ether support. And this is great because it allows you to generate an arbitrary amount of signing accounts, especially when you're in digital asset type contracts. It's really important to be able to test submitting and transferring tokens between accounts, the permissions, making sure that order B, if I'm order A, order B can't transfer tokens without my approval, and being able to test that locally on my machine instead of having to do it somewhere else is really, really nice. I can catch bugs before I even start building my application, right? So this is really important. So we wrote some tests. We feel good. So how do we use Hardhat actually? So I can go ahead and compile. I can run npx Hardhat compile. I think I've done this already, so we probably won't see anything, but it notices that there's been no changes in my smart contract since the last time I compiled it. If we look under the artifacts directory, we can actually see, the ABI of the contract in the bytecode. And then, well, now I want to run tests. Let's just make sure everything's good. I can run npx Hardhat test. Great, we're passed. This is fantastic. Our tests are good. We feel really comfortable. We have extensive, very extensive testing here. And so now we have a smart contract. We've tested it. How can we leverage a project like FireFly to start building my actual application on top of, right? How can I start building quickly, something with this contract? So the first thing we need probably is a development environment, right? We have our smart contract. I need, an implementation or a version of a multi-party system I can run on my laptop. So Nick showed this off earlier, but FireFly provides a CLI, which allows you to stand up what we call a stack, but it's really just a local, fully fledged development environment for FireFly. So if you install it, I already have, you can press FF. It gets the command line for you. And to start a stack, you can run FF init. If we do -H, we can see some of the flags you can do for customization. One thing I want to call out is the token providers. I mentioned earlier that FireFly provides support for ERC20, ERC721, and 1155. Since the smart contract we've been using today was based on and conforms to ERC20, we're going to use the ERC20, ERC721 connector. So I'm going to FF init. It's going to ask me for my stack name. I think Tech Tuesday is appropriate. Let's do 2 members. And then now we're off to the races. And this is really, I should have dash. Oops. Okay, let me do that again. Sorry, I shouldn't have had a space in the name. 2 members. All right, now let's start it up. So while that's going on, so what is this actually doing? If I go back to the slide here, it's kind of taking this picture and completely setting this up on my machine. I'm going to have 2 FireFly nodes. I'm going to have all of their dependencies, and I'm going to have the blockchain bit, that's focused around all in Docker, all on my machine, all ready for me to develop against, right? So all I have to do is start writing my app. And the cool part is, since I can set up a multi-member network, I can test the decentralization piece, right? I can test locally on my machine, having 2 apps running, how they communicate with each other, and does it work as expected before I even deploy anything, to Kaleido or somewhere else. And that's really, really, really cool. If we check back here, we'll see that it's registering my members. It's 2 members, so it has to register both of them. Should be done in a quick second. And we're done. So what do I get? Out of the box, I get a web UI for each member. Nick, we kind of stole the show here and showed it off already, but this is really just a window pane into what my FireFly node is doing, right? I can see like my network map, what organizations am I connected to, how many nodes are there? Like, FireFly supports having multiple nodes in an organization. I can see all of them. I can see the organizations at a top level, what their Ethereum addresses are. Since we run an Ethereum-based stack, what are the nodes? Nick showed this off, but we can go into the data explorer, see the messages, see the transactions. Obviously, we just started the stack up, so it's going to be empty. So this is great, right? FireFly also has generated Swagger. So in addition to the UI, we also have a full Swagger generated for you, so you can see all the APIs you can interact with. Great, so we have a smart contract. It's been tested. We have a full FireFly development environment locally. If we do a Docker PS, we can see all of the pieces that are there, right? It's 2 members, so each member has a FireFly node, each member has a tokens connector, each member has an ETHConnect connector or ETHConnect plugin. There's 2 data exchanges, which each member has one. It's for the private exchange of data between FireFly nodes. We use IPFS as the public storage bit. So each member has an IPFS, and then there's a Geth node here, which is our blockchain that we're running on locally. And this is all in Docker. It's great. I can start it, I can stop it. It's perfect for local development. So now we have our development environment, we have our blockchain, or we have our smart contract. How do we use this smart contract on FireFly? And this is the really cool on-chain logic bit. So the first thing we need to do actually is deploy our contract to this Geth node running. So I wrote a quick little script here, deploy.js. Shout out to Hayden. But the one thing to point out is it's pointing at the API and bytecode of our ERC20 with data, right? So I'm gonna go ahead and do this. Run it. So it's submitting the API to ETHConnect. It's then registering the contract on chain and it's getting this address for us and providing it to us so we can then develop against it. So this is cool. But then the next part is how do we actually make FireFly aware of this contract on chain? So we have the address, but now we need to actually make FireFly know where it is and generate some APIs for us. So this is where the on-chain logic bit comes in. If I go back to the Swagger here, there's a bit APIs down here around contracts. So the first part is we need to create the interface. We call them FFIs. And since FireFly is pluggable with different blockchain providers, our protocols, FireFly or Ethereum and Fabric, we came up with what we call an FFI, which is the FireFly interface, which is a standard for smart contracts and how they are represented. If we take a look at one, it's really just, and I have one locally here, it is really just defines all of your methods in your smart contract. It has a name, it has a version, it has all of your methods in their inputs and outputs. And this is just a common standard, so FireFly knows how to talk to smart contracts of different types, whether it's chain code, whether it's Solidity for Ethereum. This is just a common standard where FireFly defines and knows about smart contracts. So in FireFly, there is a method to generate one for you, given there is an API to generate an FFI for you. You just have to provide it, in this case, an API, but I went ahead, created one ahead of time. So now I can take this FFI, which is just a definition of my smart contract. I can hit the contract/interfaces API to go ahead and let FireFly be aware of it. So it has a name, it has a version. And the really cool thing in here, I'm going to go ahead and submit. The really, really cool thing is that this is actually blockchain pinned. So it's being broadcasted to every member of the network. So they are also aware of this smart contract. So I hit 5,000 here, which is just the FireFly for organization 0. But if we take a look in the UI, let me hide Zoom real quick. Okay, so if we go to the FireFly UI, for organization 0, we go to messages. You can see that there's a definition message. And this is just saying, hey, it originated from me. And I can say, hey, here is an FFI. I'm broadcasting it to everyone in the network. Here's the transaction ID. You can take a look, actually see what it was. If I go to the UI for organization 1, which is running on a different port, I can also see, hey, here's the same message, but it originated from someone else. And so now I'm aware of it. Great. So we have our smart contract. It's deployed on chain. We've let FireFly become aware of it. Now here's a really, really cool bit is FireFly will take that FFI and it can generate an API for you that I, as a developer, can talk to. It generates a Swagger spec and an open API spec for you to use. So how do we do that? There's a /APIs method. So I'm just going to post to send a post to that, but it takes a few parameters in the body. So it takes the ID of the interface we just posted. So if I can query interfaces here, grab the ID of that, post it here, and then the only other thing it needs is its location on chain. So I need to grab the address, the deployed contract on chain. Go ahead and submit that. And this is great. You see it's successful. I can actually query my APIs as well. And we'll see that, make this a little bit bigger. See its name, see its message, see its address. And this is actually also blockchain pinned. So now everyone in the network is aware of this API and they can use it. One really cool bit is that it generates Swagger for you. So if I go open this link up, this is actually the generated Swagger for my smart contract. It has all of the methods that I now need as a developer over an API to just use. It's really, so now I can just build an application, right? That's all I have to do. I don't have to worry about anything else. I have my smart contract and now I have a REST API to talk to it. So we have methods like, allowance, approve, transfer, mint, all of that is just available for me now to use. So let's interact with it, right? I have a Postman collection set up. Let's first let's check some balances. If I go to the UI, go to the network map, organizations, I can get my org addresses. So let's see, org 0, we should have no tokens. Fantastic. So now let's actually, mint some tokens. So I'm going to mint 1,000 to organization 0 here. And so I've successfully submitted that to the blockchain. And so what does FireFly return? It returns an ID of a FireFly operation. So I can go ahead and query that operation to get some information about the transaction I just submitted. I can see that it was of type blockchain invoke. I can see that it was successful. I can see what plugin it was. In this case, obviously, we're using Ethereum, so the plugin is Ethereum. I can see all the input parameters I gave it. I can see its output and a timestamp. So now let's go back to balance of, query my smart contract again. Great, so now it's 1,000. Really fantastic. So now let's maybe transfer some tokens. So I'm going to be organization 0 here again. I want to transfer the tokens that I just minted for myself to organization 1. Let's transfer, I guess, 100. Get another FireFly operation. You don't need to go look at it. If I query balance of again, we'll see it's 100 less because I just transferred 100 tokens. And then if I look at the balance, this other address, we'll see that it's 100. So this is great, right? We've developed a smart contract, we've tested it, we've interacted with it with FireFly. But one thing you might have noticed earlier as I talked, that FireFly actually has native support for tokens right out of the box. And one cool thing is this smart contract that we've been developing actually conforms to the ERC20 standard, right? It's just an extension of the OpenZeppelin ERC20. So what we can do is we can actually register this contract as a token pool. So a token pool in FireFly is just a construct that defines a set of tokens, right? For ERC, and they're a little different per standard, but it's just a set of definitions that define what a token is. So let's go ahead and make this contract on chain that we've been interacting with. Let's connect it to FireFly tokens so we can kind of enhance it and leverage some of the power that FireFly gives you out of the box. So I do that by making a post to /token/pools. I just provide a few attributes here in the body. It's a fungible token because it's ERC20. We're going to name it Tech Tuesday. I'm going to give it a symbol. And the only other thing I need is to actually just point it to the location of the contract deployed on chain. So I'm going to go back to my terminal, copy this address, paste it in here, submit. So it's successfully submitted on chain. Now, if I query pools, hopefully you should be able to see it. Yep, here we go. So this is the contract I just registered as a pool. See the name Tech Tuesday. We have this protocol ID here. So the protocol ID is a connector specific ID. It's kind of different per, like ERC 20, 721, 1155. It's just a unique ID that each connector will give it. In this case, it's just a combination of the address, the standard, which is ERC 20, and the type fungible token, and then some additional information. You can see what connector it hit, the status of the transaction, when it was created, etc. So now here's a really cool piece. FireFly was able to gather all the history of the transaction we ran before, just invoking directly with the custom contract. We can actually query FireFly APIs now to see all the transaction history in a rich, indexed, filterable API. So there's no having to query balance of 100 times. I can just get all of the balances I want. So let's go to the Swagger UI for FireFly right here. I'm going to scroll down to the tokens bit. And let's look at balances, right? So what I should see, I see both accounts, right? Both Ethereum accounts we interacted with earlier. I see the balance of 900. I see the balance of 100. So this is really, really cool, right? Like I interacted with this contract. It could be, 5 minutes ago. It could be 3 months ago. But as soon as I register any contract that conforms to ERC 20 as a token pool, FireFly can gather all the history from the beginning of time and really just enhances your ability as a developer, right? I can now query all of my balances. I can look at a history of all of my transfers. I can see the initial mint here, right? For 1,000 tokens to organization A or organization 0. I can see the second transfer from organization A to organization B, or 0 to 1 for 100 tokens. And FireFly just does that for you, right? I think the really cool point that I'd like to point out here is, as long as you have a contract that conforms to ERC 20, whether let's say you're a Solidity developer building some really, really complicated DeFi app, where you want full control over your blockchain and or your smart contract, you want to interact with it directly, you want to be in control, maybe it holds collateral on chain, and so you don't really trust FireFly, there's more functionality. You can just immediately, through the on-chain logic APIs that I showed you, be in full control with how you interact with your contract, but then you can still hook up FireFly through a token pool, and then you get all of the benefits of FireFly without limiting any of how you interact with your blockchain or your smart contract. You get the indexed, queryable APIs for transfers, for balances, for accounts, or on the other side, let's say you're building a smart contract or an application that is complex maybe, but not focused on digital assets that much. You don't really have to actually want to be able to write the digital assets code, worrying about transfers, worrying about tokens. You can still hook up your contract to FireFly, use the custom on-chain logic, but then you don't have to write any Solidity code or chain code for tokens, right? All you have to do is just use the FireFly APIs they provide you out of the box. So the power is, it's really, really extensible. It's really flexible. It doesn't kind of put you in a box, right? FireFly allows you to write applications, Web3 applications how you want, and then you can use the power of FireFly how you see fit. You can use it as an enhancement to your already token-based application, or you can just use the token implementation out of the box to enhance applications that might be focused in another space. It's really, really cool. There's so much here you can do. I wish I could go through the rest of FireFly, but it would take me a bit of time. Nick did a really great job earlier showing, the public and private messaging and sending data. So let's just kind of recap what we did here. We were able to write a Solidity contract and test it using Hardhat. We were able to use FireFly to set up a local development environment for my Web3 application, I was able to then deploy my smart contract on-chain using FireFly and interact with it versus using an amazing generated open API and Swagger spec. I was then able to, since my contract conformed to ERC20, I was then able to register that as a token pool, and then I get like a battery powered version of FireFly where I can leverage all of my amazing tokens-based digital assets APIs. And I was able to do that in 20, 25 minutes. And so just kind of tying this all together here, this is what I want as a developer, right? I want my tooling to empower me to quickly iterate. I want that really, really tight feedback loop where I can do everything locally. I can write code, I can make changes. I don't have to deploy to some third-party system. It's all just on my laptop, batteries included. And that's kind of what FireFly and some of these other tools like Hardhat would allow you to do. So that's all I have today. I don't know, Nick, if you have anything you wanted to add, I'd love to maybe take some questions while we have some remaining time.
Yeah, thanks, Alex. That was super cool. You really showed a lot there, and I think that was really valuable to developers as you kind of see the pipeline and see the life cycle of some pretty basic steps that you'd want to take to verify your Solidity code, write some unit tests, and then deal with those lovely interfaces to represent that on the blockchain with REST APIs. One thing to sort of just reiterate, both Kaleido and the Hyperledger FireFly community, we welcome you with open arms. It's not hyperbole. We want to know more about what you're working on, what questions you have, what's your use case, what are your requirements. So highly encourage everyone, if you found any of that remotely interesting, which I sincerely hope that you did, feel free to visit the Hyperledger FireFly wiki. There is a calendar on here that links out to the bi-weekly calls that take place. There is one tomorrow, so Alex and Nico and some of our designers, other maintainers in the FireFly space, they'll be leading that call. But there's also a really robust discourse happening on discourse, no pun intended. So the whole Hyperledger footprint is now on discourse, and there's a channel for FireFly as well. So you can very easily get in touch with our team by just joining that channel.
Yeah, sorry, Nick. If you want to go back to the slides, I forgot to share this. I apologize. I just want the Discord link and things like that are on slide 12, right? So if any of this interested you, please visit the GitHub if you're interested in contributing. There's issues open. Join the conversation on Discord, like Nick mentioned. There's the link right there. Myself and all of the other maintainers, use it very actively and talk about anything from design decisions to answering questions. Check out the documentation and then the bi-weekly community calls that Nick mentioned, where we talk about ongoings in FireFly development, and there's also an open Q&A at the end where people can just come and ask questions and get help if they want, or talk about the future of FireFly.
Yep. So the footprint of FireFly across Hyperledger, as I mentioned, it's over a dozen repositories now, so you can very easily grab the CLI, grab the samples, grab those token connectors as well, or Fab Connect. If you're a Fabric developer, I highly encourage you to take a look at Fab Connect. It just makes your life really doggone easy when you're dealing with certificate authorities or collecting endorsement policy signatures. We'd love to have a star on any of these, but you're welcome to use them as you see fit. This is all heavily documented as well, so it won't take developers longer than 30 or 45 seconds to grab the requirements and stand up your own local open source modules and have your own CLI so that you can do some of the things that I showed you and that Alex showed you. The samples are open sourced as well. And then Kaleido, as I mentioned at the very beginning of the call, this is sort of a parallel project to Kaleido, led by Kaleido developers, but also with the robust open source community. So if you have questions about just using Kaleido SaaS, you can always reach out to us directly inside of the platform right here. You can email us at support@kaleido.io or at sales@kaleido.io. Or within the platform as well. If you're just using Kaleido, we have a help button where you can reach out to our support team to ask any type of question you want. It can be commercial, it can be technical, it can be, I think I found a bug in the UI or at the protocol layer. And it's just as easy as sort of clicking this help and support button up here and opening a ticket right there. So tons of different ways to get involved and sort of continue the conversation through the FireFly lens, through the Kaleido lens, or it can just be a higher level conversation about your industry, about your use case, about your requirements as well. We have, probably close to 100 of these Tech Tuesdays we've done over the years. So we didn't spend a lot of time on Kaleido today, talking about, some of the native Kaleido features and some of the, more sophisticated configurations you can do. So if you're interested in any of those, or for that matter, need a Spanish speaking webinar, just take a look through our YouTube page here, and hopefully there's something that'll provide value for you inside of there. But yeah, I think I just want to sort of re-emphasize that it's an open community, whether you're using Kaleido, whether you're using FireFly, and we're more than happy to have further conversations about your use cases and about your requirements. So that's all I have. Just a big thank you to everyone for attending today. Hopefully you know how to get in touch with us through any of those different avenues or mediums. So highly encourage you to do so. And just big thanks to Alex for the preparation and that great demo. And stay tuned for some updates from our marketing folks and other new developments on the horizon at Kaleido in the open source space and in the Kaleido space. Kevin, did you have a comment?
Yeah, I was just going to add before we signed off here, there was one question in the chat I thought you might be able to take live. It's if my company is using OpenShift containers, can I use FireFly on OpenShift too?
Alex, you want to take that one?
Yeah, absolutely. We have, we do have, I mean, FireFly can just run in any type of Docker container. So we have some Helm charts and things set up, and I would actually take the question in Discord where we can talk more, but yeah, definitely can run on OpenShift, no problem there.
Yeah, so FireFly's architecture is very loosely coupled, microservice based, with a heavy emphasis on being pluggable as well, right? So as Alex mentioned, really the best way to kind of marry FireFly with your enterprise or your on-prem or cloud requirements is one of two things. Take it to Discord and you'll get an ASAP answer, or please join one of the bi-weekly calls that happen every other Wednesday, one of which is tomorrow and one of which will be 15 days from today. They dedicate a full half an hour, the latter portion of each of the calls, to do just that, right? To talk about specific project requirements and, to noodle on potential new developments in the FireFly space, whether that would be taken on, by the core maintaining team, or whether that might be an improvement or enhancement that, yourself as an individual or your company could help steward as well. So those are just really awesome forums to ask any type of question you want under the sun.
Yeah, we'd absolutely love to work with you, to build something to work on, anything. So looking forward to talking more.
Okay, so that's great. Big thanks again to Alex. Thanks to everyone that attended, seeing some familiar names. And for context to other folks out here, we've really spanned the gamut on all sorts of industries and use cases of people that have interest in these paradigms in FireFly and in sort of the best practices of building Web3 applications. So just at a quick glance, I see insurance, financial services and healthcare on here, just, based off of three names that I'm looking at. So hopefully that's a reflection of how robust and how powerful not only FireFly is, but Kaleido as your backend blockchain as a service can be. So thanks again. This was recorded. We'll send out the recording, and do not hesitate to get involved with FireFly or just reach out to us directly at Kaleido, and we'd be more than happy to talk. So I wish everyone a great remainder of their Tuesday, and we hope to talk to you again soon.